Hello, everyone, and welcome to the first of what I hope are many helpful videos for my class. I wanted to use these videos to be able to sort of review things that we've done in the past, as well as take a look at what we were going to be doing in the following classes. Usually these videos will be very helpful for the quizzes, so please make sure you watch them when I tell you to watch them. Yeah, that's my spiel for now. So let's just jump right in. So today in class, presumably we studied what eventually we came to know as reference frames. Okay, a reference frame is one of the few things you need to be able to describe something's motion. And the few things you need for a reference frame are an object of reference. So, for example, in class I said, "Where am I?" And you probably said, "I'm in the room somewhere." Right? But when I asked you to be more specific, usually you'd say, "I'm next to the desk, I'm near the board," something like that, right? That is the object of reference. The next thing you need is a clearly defined coordinate system. This we take for granted because they're usually provided for us, but when you need to find your own data, you need to decide what the coordinate system is. And so the things you need for a coordinate system are direction labels, right? Positive, negative, north, south, east, west, up, down, left, right, whatever you want to call it. Units of measure for distance. Are we measuring distance in meters? Are we measuring it in feet? Are we measuring it in millimeters? Whatever. And the origin, which is usually the zero marking for our distance measure. And we usually put this origin next to the reference object, or on the reference object. That's the whole point of picking a reference object. And finally, the last thing we need is a zero clock reading. So if we're taking data, when do we decide to count as the zero? Do we decide that yesterday was when we're starting to take the data? Was it 2 seconds ago? Is it going to be 5 seconds from now? So that's what they mean from a zero clock reading. And so these are the things you need to describe something's motion in a reference frame. Now, in class, we should have discussed some type of problems you come up with this. So, for example, when I was rolling around the room on my rollerblades, saying that whatever object I was holding wasn't moving, then that wasn't going with what you were seeing, right? It's because they were in two different reference frames, right? Your reference frame was one that was not moving, whereas my reference frame was one that was, and so anything that was moving in my reference frame is not seen as moving, whereas anything in my reference frame that was moving, that was from your reference frame, was moving, sorry. So let's look at an example of this. So I have drawn here a street, and you have to be very sure that you don't, when you're asked questions about reference frames, do not think about what you are seeing unless you are picturing yourself in the position of the person who the question is about, okay? For example, let's say we've got one person out here standing on the side of the road, right? With a hat, because it's sunny out. Then let's say we've got some red car. Our cars are going to be boxes because I don't draw well. Okay. Some red car moving this way with some small speed. And let's say there are 2 people in this red car. Okay? And there are 2 people moving this red car. Finally, let's say there is a blue car coming up from behind. With 1 person in it. And this car is moving much faster than the red car. Okay? Alright. So, my question is this. Let's start with, let's say this is person 1. Let's get a different color going. 2, 3, and 4. Okay? And let's say that this direction is north. We have to pick a direction, right? And let's say this direction here is south. So, first question. In what direction does person 1 on the side of the road here see the other 3 people moving in? Okay, again, what direction does person 1 see the other 3 people moving in? since this one's easy, I will fill it in so that you know what to do later. So person 1, let's say there's person 1, person 2 is moving north, person 3 is moving north, and person 4 is moving north. Alright? This is kind of what I want you to do for this example. Now, do the same thing for number 2. Okay? I want you to take a minute, pause the video, and do the same thing for number 2. Okay? Pause now. Alright, so you should have paused. If you didn't, spoiler alert. So person 2 sees person 1 moving south, right? Because they are moving forward. If you were in the car looking out the window, you would see this person moving south. Person 2 sees person 3 not moving at all, right? Person 3 is sitting next to them in the car. So person 2 doesn't see person 3 moving at all. If you were in the car and you were looking at person 3, you yourself know that you are moving. But if you were to look through your scope at person 3 without any reference to anything else outside, you would see person 3 sitting in the car with you. They would not be moving. Person 2 sees person 4 moving in what direction? North. Alright? Person 4 is speeding up, so person 2 sees person 4 moving in the north direction as well. Alright. Do the same thing for person 3. I'll give you a minute, pause the video, try it yourself. Okay, so I'm going to assume you did it. Turns out, if you do person 3, it'll be the same as person 2, right? So 3 and 2. Only this is 2, 3, right? 2 and 3 see each other not moving. Alright? And so last one, do number person 4. What direction does person 4 see everyone moving in? Pause the video, try it yourself. Go. Okay, should have paused. So person 4 sees person 1 moving south. I'm sure you knew that. Person 4 sees person 2 moving, you guessed it, south, right? Because person 4 is moving so much faster, everyone else looks like they're going backwards, even though person 2 and 3 are also moving north. And you can see that they are also moving north. From your reference frame, if you took your reference frame, your car is the object of reference, everything else is moving around it. With you speeding up faster than person 2 and 3, you see them moving south, okay? Just because you are moving faster. Alright, so person 2 and 3 are both moving south, alright? And you yourself, you obviously see yourself as not moving, but that's not the problem. Alright, so this is a quick example of what the kind of questions I might ask you for a problem like this, okay? They might be more complicated, they might be less complicated, maybe you'd have to decide what direction and how fast people are moving in, but this is just an example of what kind of question I could ask you with this. Alright, great. So until next time, see you in class. Bye.